So here are your notes for today. We are doing combined event probability, so more than one event occurring at a time. So the first thing that's on here is just kind of describing the difference between independent and dependent events. So independent events, just like it sounds like, because you know the meaning of that word, the outcome of one event does not affect the outcome of the other event. So these bold words right here are the most important. And then to find the probability of two independent events, you multiply the probability of the first event by the probability of the second event. So the key here is this multiplying idea. And we will do some examples in a little bit. The next term on here is dependent events. So much like you would think, in dependent events, the outcome of one event affects the outcome of the other event. So for this probability, you still multiply. So the probability of two dependent events is found by multiplying still. But you have to, you multiply the probability of the first event by the probability of the second event after the first event has already occurred. So you take into account the first event has already happened. We will talk more about this in the examples. So in both cases, you multiply the probabilities. So the first part of the notes is just making sure you understand the difference between these terms, independent events and dependent events. So this first little section right here, we're determining whether the events are independent or dependent. So it's just going to give us two situations, and we say whether they're independent or dependent. The first one is flipping a coin and rolling a die. So these two things are definitely independent of each other. The outcome of one does not affect the outcome of the other. So this is independent. The next one here says choosing a card from a deck and then choosing another without putting the first card back in the deck. So this is kind of key here. So like if you had a deck, like a standard deck of like playing cards is 52 cards. So if you were to take one out and then not put it back, you only have 51 cards left in the deck. So the probability of the first one does impact the probability of the second one. Whenever we're not putting something back, so whenever it's without replacement, that's called, it's always dependent every single time. If you're not putting the item back, whether it's a card or no matter what it is, if you're not putting it back, it's always dependent. This says choosing a card from a deck, replacing it. So you are replacing it now, shuffling and choosing again, that's independent. So with replacement is independent, without replacement, if you're not putting back, is dependent. So this is actually just like practicing with those formulas of multiplying. So it says a month is chosen at random, then a standard die is rolled. What is the probability of getting February? Then a number less than 5. So the probability of getting February in general, just going to kind of underline that and write its probability right here, is 1/12, because that's 1 out of the 12 months. A number less than 5 on a die, the probability of that would be, there's 4 numbers less than 5 on a standard die. So it has 6 sides, and then 4 of them are less than 5. So this would be 4/6, which simplifies to 2/3. So those are the probabilities of each individual event. And then in order to find the probability of this combined event, what we do is we just multiply those. So we take 1/12 times 2/3. And it would be fine if you didn't simplify that 2/3 first. But 1/12 times 2/3 is 2/36. In other words, it's 1/18. Whenever we're giving probability, we can give it as a simplified fraction or as a percent or even as a decimal if it doesn't tell you which way. So usually I would give the simplified fraction or I would give the percent. So if you take 1 divided by 18 on the calculator, it's about 5.6%. And we do want to include that decimal point to the nearest tenth. Don't round it to like 6%. I think that's a little too much rounding. So the next one here is a standard die is rolled 2 times. What is the probability that it lands on one both times? So this is independent. The first roll of the die does not impact the second roll. So again, we're just going to find the probabilities and multiply them. So in this case, the probability of landing on 1 for a standard die is 1/6. So just take 1/6 times the probability that it lands on 1 the second time is also 1/6, and that gives us 1/36. If you divide that on the calculator, it's going to be about 2.8%. So either answer is fine there because it doesn't tell us how to give our answers here. The next one here says there are 3 green markers, 6 yellow markers, 4 red markers, and 12 blue markers in a pencil box. A marker is drawn, not replaced. This is key, so that means the events are dependent. Then another marker is drawn. Find each probability. So the probability that they're both blue, there are 12 blue ones out of a total markers, add all those together, you should end up getting 25. So there are 12 blue markers out of 25. So the probability of picking a blue one the first time is 12/25, so about 1/2. But then after you pick that blue one, you're not putting it back in. So there's only 11 blue ones left out of a total of 24. So if you multiply on this, you end up getting 132 out of 600, which you could simplify. Let's see, that's going to simplify to 11/50ths. So that would be one acceptable answer. Or remember, you can always give the percent. If you divide 11/50ths or 132 out of 600, it's going to be about 22%. So either one is fine. So the next one is the probability of picking a yellow marker. So how many yellow? There are 6 yellow out of 25 total. And then green, there are 3 green. And then we already picked the yellow one out, so our total number of markers is now only 24. Multiply those fractions, you get 18 out of 600, which simplifies to 3. Sorry, that was a bad 3. Simplifies to 3 out of 100. So that would be fine. That's one way to give your answer, or 3%. So that is it for the first page of these notes. We're going to move on to the back page now. So the back page of the notes is about conditional probability. So conditional probability, we start with just the definition. It's a probability of an event given that another event has occurred. So the notation here is a little bit kind of involved, so I'm just going to explain it a little bit. This P of A / B, we would read that out loud. The probability of A given B. So that little like slash in the middle, it's usually like a vertical slash like this. You read that out loud, given. So it's not a fraction, it's just notation that means A given B. There's a formula here. So in order to find the probability of A given B, what we do, by the way, whenever you see the capital P here, remember that means probability. We're going to take the probability of A. I don't know if you've seen this very much before, but this upside down notation here, this like upside down U, means the intersection of the events. Which in other words means A and B. So this means the probability of A and B divided by the probability of B. So just B occurring. So both events divided by the probability of the one that's given. So probably still like a little bit confusing, but we'll do a couple examples down here. So this one says it's a table showing the results of a poll of 150 randomly selected middle school students who were asked if they take French or Spanish. If a random student is selected, determine the following probabilities. So usually when I see these like two-way tables, I think it's probably a good idea to calculate the totals because they'll probably be helpful. So if you add the whole French column this whole column is going to add up to 82. If we add the whole Spanish column, this whole column is going to add to 68. Let's add the rows as well. So the 6th graders add to 42 when you take 19 plus 23. The 7th graders add to 37. And then the 8th graders are going to add to 71. So whether we total horizontally, take these two numbers and add them together, or vertically, we should get the same total of 150. So it's 150 total students. So the probability of randomly choosing a 7th grader who takes French, it looks like the 7th graders who take French, there's 25 out of a total of 150. This is not conditional probability. It's just a regular probability. So 25 out of 150 simplifies to 1/6, which is about 16.7%. So either the fraction or the percent are fine. The next one, if I were to read this out loud, it's the probability of choosing an 8th grader given that they take Spanish. So it's a given our population of students is only the ones who take Spanish, not all 150 of them. So we can apply our formula here to do a conditional probability up here. So we're using, for both number 2 and number 3, we're using this formula up here. So we take the probability of both events over the probability of the thing after the slash. So we want to do an 8th grader and taking Spanish. So 8th grader and taking Spanish, looks like there's 33 of them. Over in our formula, we always divide by the probability of the thing after the slash. So taking Spanish in general, we already found the total of that column, that's 68. So it's 33 out of 68, or you can give it as a percentage, so, or 48.5%. So either one of those would be fine in that case. And then the next one is the probability of randomly choosing someone who takes French, given that they're a 6th grader. So our population here is not all 150 kids. It's just the ones who are 6th graders, because it's given, it's a condition that it's a 6th grader in the first place. So we'll apply our formula again. Remember, this is the formula. So we take the intersection of the two events, in other words, taking French and a 6th grader, which is these 19 kids. Out of, you always divide by the probability of the second thing, which is the 6th grader in general. We already totaled that row, it's 42. So 19 out of 42, can't simplify that. Or that would be about 23.1%. And then just one more example here. So this says there are 100 people working on a performance. There's 52 dancers, 12 stage technicians, and 36 musicians. Among the dancers, 14 are ballet dancers, 20 are jazz dancers, and 18 are modern dancers. And then we're asked for a probability here. It says, what is the probability of selecting a ballet dancer from those working on the performance, given that the person selected is a dancer? So I always like, especially when I see the word given, I recognize that's conditional probability, which is important. And then I want to like translate it to a probability notation statement. So this is asking for the probability of selecting a ballet dancer or a ballet person, given that they're a dancer. So this is that vertical slash for given. So then what I always do is I just apply that formula from the top of the page, again, the one we used on the previous example. So in that probability, or in that formula, it's going to be, we're finding the probability of ballet and dancer. Out of the probability of a dancer in general. So a ballet and dancer, there are, let's see, up here, there are 14 ballet dancers. So that top number is going to be 14. So this is 14 because of this. So 14 is going to go on the top. And then the probability of a dancer in general. And what we want to do for this is we want to add all these dancers together. We have 14 or, oh, sorry, it already tells you up here there's 52, so we don't have to add them. So there's 52 total dancers. So this 52 is going to go on the bottom of that. So 14 out of 52 simplifies to 7 out of 26. Or if you want to change it to a percent, it's about 26.9%. All right, so that is it for our last lesson, kind of short notes. So at this point, you're going to receive your homework. So work on that for the rest of class. Tomorrow during class, we're going to work on a test review. So if you aren't in class tomorrow, just make sure you check Google Classroom. The test is on Wednesday, so 2 days from now. Just keep in mind, it's a smaller test. It doesn't count for quite as many points, but it still has the ability to affect your grade quite a bit. So right now you're going to work on the homework for Chapter 12, Day 5, and then just keep in mind there's a Chapter 12 test on Wednesday. All right, I will see you tomorrow.